Hello, everybody. I'll be the moderator for this session. My name is Tato. So we welcome you all and thank you for attending this conference. And I'll be your host for this session. We appreciate you all for joining today. Thank you. Am I still audible?
You are that.
Thank you. Thank you. Let me point out some things. So before we begin, just be aware that the session will be recorded and thus posted on YouTube. So also it'll be followed and posted on our social media platform. Just be aware that should you have any questions, just tap them out on the Q&A page on the Hopin app that we're using to host. So yeah, I'd like to welcome Rachael. Now, Mwatela, yes. I hope I'm not butchering it. Hope forgive me. And Sigu Magwa. They'll be co-speaking today. The topic is standing on the shoulders of giants. Also, remember our theme for today is Elixir as a power tool. So should you feel uncomfortable about the sessions being recorded, just be aware that you can silently just leave the room, please. So yeah, we give it to Rachael and Sigu. Thank you.
Awesome, Bato. Thank you so much. Yeah, I think it's been a very long day.
Yes, it has.
It's now time to do a presentation on the same. So I'll just start by sharing our slides right there. No, I need to share my screen first. So I'll do that, share. Which screen should I be sharing? That one. Let's just confirm if you can see the screen. Can you see the screen?
Yes.
Yeah, it's very much visible.
Awesome. All right. So the title of the talk is Standing on the Shoulder of the Giants, and we left it a little bit vague, just so that you can be curious enough to get in and try to understand, or just trying to see who the giant is and what you're going to talk about. So as you can see from the subtitle, we are going to talk about how different people leverage on battle-tested platforms. I'll start by introducing who we are. Can I start by myself?
Yes.
Okay, thank you. So, my name is Sigu Magwa. That's like the most common avatar of me. And OpenAI actually introduced DALI 2, I think. So I uploaded my image to DALI and just gave it the image so it can do any creative thing. And this is what it came up with. So maybe I have a new avatar. Maybe not. So yeah, I did electronics and computer engineering back in the university. After that, I dabbled in electrical and electronics engineering. Then for 1 year after university, I did practice electrical engineering, but quickly got bored with it. So I switched over and started learning how to program. That's when I stumbled upon Ruby on Rails. After stumbling upon Ruby on Rails, I did it for a while, also studied Ruby, did a couple of production ready and viral applications in Ruby. Then started working where I also built some mobile applications using Ionic, and Ionic was back then dependent only on Angular. So it was fun time back then. Quickly, 3-4 years ago, I moved over to Elixir, and I've been concentrating on Elixir and just learning a lot more about it. That should be enough of me. Maybe you're now curious to hear who my co-presenter is. Yes.
Yeah. So Tato, you have not butchered my name. Don't worry. My name is Rachael Mwatela. I am a full stack developer currently working at Hey Misa. And what Hey Misa does is build a platform for planning for future. I mean, if you plan to have kids in the future, all those things we help you prepare for that. Before that, I have been a clojure dev for a while, for 3 years, I think, 3 or 2 years thereabout. Clojure is my first love, and apart from that, I enjoy doing community work and talking to young ladies and mentoring young ladies. Fun fact, this guy tried to teach me Ruby once, once upon a time. I was really bad at it. But right now, I can believe I'm a good programmer, at least good enough. So, yeah.
Maybe object-oriented wasn't your thing.
Maybe.
Yeah,
Maybe,
we just
yeah.
never know. So enough of ourselves. So really, we wonder, what's the plan for today? What really are we going to talk about? So just a brief of what you're going to go through. The first thing that we're going to talk about is runtimes. So we're going to do a very quick one on the runtimes and make you understand what a runtime is.
Yep. The other thing we're going to talk about is Jerry. I think you remember that from campus. I think you remember in campus?
Back when I was doing electronics and computer, I did like programming, but we would still install JRE, JVM,
Yeah.
JDK, Java. Yeah, there was a lot of Java stuff. So
today we're going to go in depth with it.
yeah, I wonder why we're talking about all this and this on Elixir conference. Maybe the relevance is in a
Let's
few.
see.
All right. So again, don't worry, we're going to talk about the beam. So a little bit explanation of about the beam, what it is.
And as I said, Clojure is my first love, so we're going to talk about Clojure and how it leverages on JVM.
Oh, awesome. And also just quickly take you through Elixir and how it actually leverages on the beam. Then after that,
We are going to do some demo.
yeah,
I'm
thank
going
you.
to take you through Clojure.
Awesome. I can't wait for the closure section. I'll give you very hard
Wow.
assignments for the same.
Let's see, bring it on.
All right, let's talk runtimes. So imagine if you had, I'm assuming you're interested in like writing Elixir, or you currently writing Elixir, wherever you are, or Clojure. Imagine if you had to write Elixir for each operating system. Imagine if you had to write Elixir for Windows, Elixir for Linux, Elixir for BSD, Elixir for Mac. Imagine if that was the case. That will be an actual nightmare. So I'll quickly take you through source code in Elixir. If you scan that code, it's going to take you directly to the source code of Elixir.
Yep.
And if you notice this, I've lost my pointer.
There you go.
Where is my pointer? Okay, so if you notice on what I've highlighted, this is a file.open function
Okay.
in the Elixir open source code. And if you check on the second def open, the body of that actually does colon file.open. And that tells that actually whenever in Elixir you start with a colon, you're basically calling Alan. So in this case, you can see Elixir is calling Alan to open a file. It's delegating that to Alan. Okay. So where am I heading to? I'll explain what a runtime is. In the background, you can see the world record.
Our champion.
Yeah, the person who breaks his record twice without anyone else trying to break it in between.
Yeah.
So a runtime, as a Kenyan, if you hear about a runtime, there's a popular tribe where actually the champion comes from. It's the Kalenjin tribe. So whenever Kenyan talks about running, they think about the Kalenjin tribe. So in software, these are a little different. And the runtime actually is what you have on the computer where you're actually developing the software. And it's also in the computer where you intend to run. So when you develop on computer A and you pass your application to computer B,
Yes.
the computer, whatever makes it run on computer A needs to be available on computer B. So that can be called a runtime. Okay. A runtime can help you do things like memory management. It also helps the applications be able to access its variable and interface with operating systems. So the reason we're talking about this is started by telling you to imagine if you could write for each OS. So imagine a runtime as someone else's problem that you don't need to care about, that actually thinks about how to run in each OS, so that if you write your code, your Elixir code in Linux, it still will run on whichever the other platform. Okay. So when you talk about runtimes, I can also quickly talk about bytecode, because we might need to talk about bytecode. So the bytecode is actually what your code can be compressed into. Let me use the word compressed. So it reduces how much you depend on your operating system and your hardware. So if you need to talk to the GPU, the CPU, or whatever it is you want to talk to, bytecode actually enables you to reduce that dependence. So whatever your platform, you're good to go. So that's the second point. It allows you to run across different platforms.
All right.
So too much explanations. Maybe we can talk about the JVM.
We can talk about the JVM. So
in an Elixir conference.
Well,
okay.
I can start. Cool. So JVM, as you all know, it's a virtual machine, Java virtual machine. But what most people don't know is that JVM does not exist. It's just a concept.
Oh.
So it's platform dependent. That means it depends on the operating system. So if you have Linux, then you install JVM for Linux. If you have same thing to how you have web browsers.
Okay.
Chrome for Linux, Chrome for Mac, and all that.
Okay.
So it's the same thing. And JVM has a couple of duties. It loads the code, it verifies the code to see if it meets the rules, and then after that it executes the code, and then finally it provides a runtime environment for you.
Awesome. So is this related to what I was talking about it being someone else's problem? So is the JVM someone else's problem so that you can write your code, so that it can run across different computers?
Yes.
Oh, awesome. So we're heading somewhere on this.
So we just mentioned that JVM does not exist. What do you think we should do about it? What can we use to use JVM?
Okay.
So that's where JRE and JDK come in. So JRE is the runtime environment. Since JVM is a concept, JRE is an implementation of the concept.
The runtime I just talked about.
Yes.
Okay.
Got it? So, and then we have the JDK, and that's the development kit. And most times the JDK also contains the JRE.
Oh.
And for those who maybe get confused what the development kit is, it just helps you as a developer use the Java tools. So you can have Java C, the Java compiler, Java docs, and all those.
Okay. So can we consider this as a set of tools that you use to do your development?
Exactly.
Oh, perfect.
Yeah.
All right.
So now I'm going to talk to you about Clojure, and hopefully I'll convince you to move to Clojure.
Okay. Actually, before you talk about Clojure, the first time I looked at Clojure, I saw a lot of brackets.
Okay.
So it brought me back to the days of Lisp. So I had studied Lisp for a while. So this was when I was doing structured interpretation of computer.
Yep.
So when you do this, it actually uses Scheme, which is a Lisp dialect.
Very true.
Yeah. So later on, I looked at, I was just curious to know more about Lisp, and I found out that it was actually specified in 1958. Wow. Kenya didn't even have independence back then, most African countries.
Yes.
Yeah, and fun fact about Lisp is that it's the second oldest high-level programming language that is still being used today. And this is after, I think, Fortran. Yeah, after Fortran, then it should be there. Then again, Lisp is full of brackets. So as you can see on the top section of the code, we're declaring a variable, assigning it to 10. Yes. Then we can add 32 to it. Then we multiply the result, foo times bar. For you to do the same on Lisp, you actually have to introduce braces.
Yes.
And lots of braces.
Mm-hmm.
So I wonder, clojure has a lot of braces, so I don't know whether it has some relations with Lisp or anything. So I'll just let you tell us more about it.
Okay. So, as you've mentioned, Clojure is a functional programming language, and it has some Lisp concept in it. So, based on like when you hear the talk from the founder of Clojure, Richiki, he talks about the fundamentals of Clojure and that being dynamic in that it allows dynamic typing, and then it's functional. So you have some of the, can I say,
it's functional just like Elixir is.
Exactly. So you can use immutable data structures and all those things, pure functions. Then it's hosted on JVM, and we have just talked about JVM. And then it has support for concurrency and open source, so anyone can contribute to it.
Okay.
So we are going to focus mostly on the hosting on JVM, and how does Clojure leverage on having it on JVM. So Clojure is a hosted language. That means it
it runs on top.
Exactly, it runs on top of it. So why Clojure chose JVM is because it provides stability and performance and security. And also there's access to existing Java libraries. So you can always use Java functions in Clojure, and it's very easy.
Oh.
Yeah, it's easier for somebody who has done Java to do Clojure.
Okay. Yeah. You're making me think like maybe Clojure is Lisp for someone who doesn't want to write Java. But let's proceed and see if that's the case.
Yeah. So still on the topic of compiling and Java JVM, we're going to see how Clojure compiles to JVM. So when you have a Clojure function, it will compile it down to a class with static methods, and then from that we will get a JVM bytecode, and then that now it gets to be run on the JVM.
Oh, yes. Okay. So you've talked a lot about Clojure, JVM, scheme, and all that. So where really do we use Clojure? If I learn Clojure,
how can you best? Yeah, good question. So it's a very diverse language. Can I say that? Like you can use it to pretty much everything. But I'll talk about the few times that I've used it, like in standalone applications. I've seen people use them in financial system. Just recently, we were talking about the founder of Nubank, the founder of Clojure, who now works at Nubank as a CTO, and majority of the developers there are Clojure devs. And then you can build websites with it. We have something called ClojureScript. ClojureScript is just Clojure compiled into JavaScript.
Oh,
I think that's homework for someone to do and see how that is compiled to JavaScript.
So Clojure was compiled down to Java, and now Clojure can be compiled to JavaScript.
And that's
very interesting.
That's the beauty of it being a hosted language.
Oh, nice. Yes. So on the same topic, you're talking about the new bank. So something interesting about Nubank. The first time I heard about Nubank, first of all, I heard that they have about 700 devs, 700 developers. It's in Brazil. So the first time I heard about it, it's when it acquired. It actually bought out a development agency called Plataformatech. And Plataformatech is the company where the founder of Elixir was working before it was acquired by Nubank.
Nice.
Yeah. So the whole team of Plataformatech, where Elixir was born, was moved to Nubank to write Clojure. Or maybe Elixir, I don't know.
Good reason to move you to Clojure.
All right. I think we've had enough about that. And maybe we're wondering, the Beam, what is the Beam?
Yeah.
Who is it for? And so the Beam is actually an Erlang runtime system. So it compiles Elixir code down to bytecode. All right. So this is why we started by introducing bytecodes, runtime, and all that. So we now understand what the JVM is.
Yeah.
And now we are at the Beam.
Yes.
So the Beam think about the beam as the JVM.
Mhm.
Okay.
Mhm.
So I'll take you through how Elixir compiles its code.
Okay.
Okay.
Mhm.
So, and before we talk about how Elixir does it,
Mhm.
we can talk about how Erlang does it. Okay.
Yes.
So if you have your Erlang source code,
Mhm.
right, you just typed a lot of Erlang without parentheses.
Mhm. Without?
Then, yeah, without the brackets.
Okay.
Then Erlang is converted into the abstract format.
Yes.
All right.
Mhm.
Then after that, we're going to have the core Erlang, what you call the core Erlang.
All right.
Yeah. After the core Erlang,
Mhm.
then we're going to end up with a bytecode.
All right.
So the bytecode for the Beam VM.
Yeah.
Yeah, the Beam is called the virtual machine.
Yes.
Yeah. Another quick fun fact: the Beam VM is actually a predecessor of the J. It's not the JVM. I've forgotten the name, but there was another virtual machine that it's there's someone called Joe Armstrong
Yes.
who was working at Ericsson where Alan was born.
Mhm.
So he's the first person who created actually a virtual machine before the Beam came in.
Okay.
Yeah.
Mhm.
So enough of the Beam. So we can now talk about Elixir.
Yes.
So if you look at Elixir, you usually have your Elixir source code.
Yes.
And the next step that Elixir does is that it expands your macros.
Mhm.
After expanding your macros, then it goes down to what Elixir was doing. So it actually joins Elixir at the journey.
Okay.
Yeah. So
Makes
I'm
sense.
assuming this is exactly what happens with Clojure, JVM, Java, and all that.
Yeah.
Okay.
At some
Yeah.
point.
Yeah. So
Just the queue.
yeah, it's been about 20 minutes of us talking about all this. So maybe you're wondering who the giant is.
Who's the giant?
Who the giant is in this case. So the image on the right, again, just have to talk about it. The image on the right, again, was generated by DALI. I went in there and I typed a few phrases, a giant. So you can see the image and the ant is trying to climb on top or on the giant's shoulder.
Mhm.
Okay. So what we mean by the giant and riding on the giant's shoulder is how actually languages skip or loop frontly, how they actually jump into adoption
Yes.
by using existing technologies.
Mhm.
So we've talked about Clojure and how Clojure uses the JVM, right?
Mhm.
Java uses the JVM,
Yes.
and now Kotlin again uses the JVM.
Mhm.
And Scala uses the JVM.
Yeah.
So all these people are actually riding on the
One
JVM,
person
and the JVM
is the giant.
is our giant.
Correct.
Let's go to the Beam, being our giant. Elixir is literally riding on the Beam, and you can see that from. Do I have to wait for this to load? You can see that from how Erlang was compiling down.
Mhm.
Yeah, and Elixir was actually just joining after doing the macro expansions
Okay.
on this particular slide.
Mhm.
All right. So we can have Elixir on the Beam. You can have Gleam on the Beam. Erlang also run on the Beam. And the last interesting one is Clojure on the Beam.
The very mighty Clojure.
Yeah. So we also have Clojure on the Beam.
Oh.
Yes.
Wow. I didn't know about that.
Yeah. So enough of that. We've talked a lot about Clojure, the Beam, the runtime, and all that. So I need to see a few brackets.
Let's
A few
do
brackets.
that.
So I think I'll go and I can ask you what to do in Clojure.
Yes.
All right. So number one is maybe you said Clojure is a functional language. So when I think functional, I think about map, filter, reduce, yeah, all that. So you can show us how we can do. Maybe we can sum elements in a list, an array. I don't know how
we call it. Okay.
Yes. So I can start by sharing the correct screen again.
Yep.
So we'll stop this and share the terminal now. There you go with the terminal. I need to zoom in. I think we're still sharing. So I need to zoom in
think so.
and move. So you can
Switch.
Yeah, you can switch. Check the switch.
Okay.
Let's write some closure.
So in case I'm slow, Sigu is using what do you call this?
Mechanical keyboard.
Mechanical keyboard, and it may slow me down. That's not an excuse. So Sigu mentioned we want to do to sum up an array, but well, what we call them in closure. Oops, this is why I told you. Cool. So what we call
You need to get into
I need to get into the repo
REPL,
first.
yes.
Sorry.
That's the REPL.
Yes.
Okay.
So I think REPL also depends on JVM as well.
Oh, the REPL
But
also? Okay.
Yeah.
Interesting.
So what we'll do really is create a list, my list, and give it some integers.
Okay.
1, 2, 3, 4, 5. Right?
Bracket I was talking about there.
Yeah. So the brackets, when you use the brackets in closure, it means it's an array.
Okay.
Yeah. We call them
that's
arrays.
the square brackets.
Yes.
And the surrounding brackets?
And the surrounding brackets, that's how you start a function or a variable in closure.
So it's like scoping, maybe. Okay, let's proceed.
Yes. Defining.
Okay.
Yes. Def is defining, right? So English. So when you do my list, now you should be able to have your array.
Okay.
Yeah. So what you want to do is sum, right?
Yes.
So we are going to use threading, and we have two types of threading in closure. This is, we call it second threading, or
Okay.
second, some people call it second macros, really depends. So this passes your value as the second argument in your, so you just see how we'll do it.
Okay.
So we have my list as our value.
Okay.
I think if I enter, so we want to thread with them. So do you want? We just want to sum, right?
Yeah, we just want to sum.
Okay. So shift that. We'll use
map maybe.
To sum.
Yeah, we can map through and add, or there's another way of doing it.
Okay, we can do that.
Okay.
Then you don't need to do. You don't need. Let's just do that.
Okay.
Map, and then command hash. How do you do hash here?
Oh, I can help you type in. So we have, you're saying we type hash.
Yes, and then open parentheses.
Open parentheses.
And then we want to add, so you use the function, the plus function.
Okay.
Yeah.
Plus function.
And then we want to pass the first argument.
Okay.
What do you want to add it with?
You want just to sum, or we can add one to each element.
To each element.
Yes.
Okay. So call the first value of the list.
The first value of the list. How do you do that?
So you can use
percent.
Percent.
Okay, you can do percent.
Yes, and then the value that you want to add it to.
Oh, so we can do 1.
Yes.
Okay.
Then close that.
Okay.
And then close them up.
Close them up.
And then close the whole function. Okay.
Whoa.
This for the first.
Okay.
Yes.
Okay.
And then enter.
Enter. Oh, yeah. I think I can realize why we got an error.
Mm-hmm.
Yeah. Live sessions are never that.
Oh, space.
Yeah. So we can remove that space.
Mm-hmm.
We do. I think we need to start with map.
Mm-hmm.
If I'm not wrong.
Yes. And then the function.
And then the function.
The anonymous function. Yes.
Okay.
Then
nice.
So you get a list with your values added to them, summed up.
Okay.
Yes.
So this is basically mapping in closure.
Closure. Yeah.
Okay.
You don't really, for something really simple as this, you don't really need to use the threading.
Okay.
But if you had if you had other functions that you wanted to do to it, let's say if our list, we wanted to multiply it and then filter and then map, then we would have used the threading.
Oh,
yes.
Awesome. So I don't know if we still have time. Organizers can let us know if we still have time. Then
We can try another.
yeah, we can do another thing in closure, which is getting
10
using.
minutes to go. You still have time, guys.
I think we'll
okay.
we can let that be maybe.
Q&A.
Yeah, maybe.
Okay.
Okay. So if you want to learn more about closure, there are some more interesting codes that yeah, that you can learn from. So for example, let me see if we can get more closure right here. Just a minute. Right here.
Yeah.
Yeah. So in the interest of time, I think you can explain. I might have to zoom into this.
I think so.
It's not as visible. What if I maximize? Still not yet. How do I enlarge?
Okay.
I'm not sure how to enlarge this.
But
Wait.
can they see?
Yeah. Can you see the code?
Yeah,
Someone
we
just-
can. Yeah.
Awesome. Okay, so you can take us through what's going on there.
So I think majority of languages have reduce in
Mhm.
functional programming. I don't know about OP.
Yes.
I'm not being ignorant, but so what's happening here? We are using reduce, and reduce in Clojure can be used in two ways. So if you have a function and a collection, but you don't have accumulator,
Mhm.
yeah. So we can do it in this way, where you have you have defined your list, right? And
Okay.
then you do reduce, and then plus is a function, and then my list. So what happens is this function will apply to the first argument in first item in the list, and the second item, and then that keeps repeating itself as you go.
So this is the same as the class that I did and one.
Mhm.
So basically, you're telling it to apply reduce on the list
Yes,
and sum the arguments,
yes,
the first and the second,
yeah. So
in that order.
yeah,
Okay.
eventually you will get sum of the total of all these numbers.
Okay.
Yeah, but if you have a accumulator or a value, in this case, let's say we have a map, and we want our map to, or a map is object in JavaScript.
Yeah, and we also have maps in Elixir.
Oh, cool.
Yes.
Okay. So if you have a map and you want this value, you want to add it by 1, right?
Mhm.
So we can use reduce to do the same thing. So you'll have reduce, and then reduce will take the value, which is an empty array, because you want to
That's the initial
put it back.
accumulator.
Yes, the
Okay.
initial accumulator, and then we have the map that we just defined up here.
Okay.
Sorry.
Okay.
Sorry. So once you have these two arguments, just referring to the definition here, we have our function, and our function takes the initial value and then destructures the map. So we have a key and a value.
Yeah. Interesting. In Elixir, we call that pattern matching.
Instead of
The
destructuring.
destruction.
Oh
Yes.
wow, okay. Nice. So once you have those arguments, what you want to achieve is put back the values, but then
Yes.
into the map, but then make sure the value is summed up.
You increment, yeah,
Yes,
by
you
one.
increment it by 1.
Okay.
So we're expecting the key as it is, but then we want the value to be incremented by 1. So into is just put this into this.
Oh,
Yes.
nice.
And that's
Awesome.
it.
Awesome. Thank you for taking us quickly through closure. Just to get back to the slides. I hope you can see the slides. Yeah.
We're done.
We're done?
Mm-hmm.
I don't know if you managed to convince anyone to get into closure.
I hope so. If not, I'm here.
Yeah, so when we're trying to get the Q&A, it was fun relating how closure depends on the AVM and the Elixir depends on the beam.
Yeah.
and just how different languages ride on the ones we call the giants, because the Beam was, I think, in the 80s, and Elixir is around 2015. Clojure is about 2012?
17.
2017?
Oh, no, 2007.
And 7.
Yes.
Oh, okay. All right, any question?
Yeah, there's a question from Getty.
Okay.
Am I still audible?
Yes.
We can hear you.
Okay, cool. Getty has a question. So what type is, so there's a braces. Before I go into questions, by the way, that was sort of like a conversation, so we enjoyed that, guys. Just a slight comment. I see that clojure compiles to Java and JavaScript. So it is so accustomed to having so many parents, hence the many parentheses, hey? So like, yeah. And it also has a garbage collector to clean up after its messes. So that is one of the sort of neat things about clojure, I would say. Anyway, the question from Getty is, what data type is this? So the open parentheses and then numbers separated by spaces. So, and she's asking that, what data type is that? Also, it's weird how the return type of an array is not comma separated.
Okay. So, as you mentioned earlier, clojure is dynamic. So it knows by default what the data type is. But in this case, this is an array.
Okay.
Does that?
It's an array.
Yes.
I think in Elixir we call it list because Elixir uses linked list. But again, I'm finding it hard to understand the question because I can't see the code he's talking about.
Okay.
Yeah, so I don't know whether they're talking about the list or
the map. Oh yeah, baby.
Yeah, or the map.
No, it sort of looks like an array, because the question is, perhaps let me just read it as it is. What data type is this? And then she has an open parenthesis. She has numbers inside that are separated without any commas. And then she says, also it's weird how the return type of an array is not comma separated.
Without commas.
Yeah.
Okay.
Yeah. So yeah, that's an array, and clojure has no problems with you putting commas or not, as long as you space them to show that that's a different item from the other one in the collection.
So you can even use a semicolon.
Yes. Is semicolon a data type? What data type is that?
No, I can separate with semicolon, so I can do one semicolon, two semicolon.
You can.
So it's either comma.
If you put a semicolon, it will identify it as an item and complain.
Okay.
Yeah.
So it has to be one, either a space or a comma.
Yes.
Okay.
Exactly.
Awesome.
Also, I would add, if there's anybody, since it also compiles to JavaScript, if there's anybody who's coming from JavaScript, if you actually, there's a library that is from the clojure community that you can use to make your data immutable by default. That is called Mori. It's MORI. So it is these weird data types as well. So just check it out.
Awesome.
Can I add on top of that? When you talk about ClojureScript, I know that people who have done Ruby before, and we have a framework in ClojureScript called Frame, which borrows a lot from how MVC structure. MVC structure. The architecture of Ruby. So it's really easy to learn, and I mean, you should try it out if you're doing JavaScript and you've done Ruby before. You'll love it.
Yeah, and again, let's not forget that Clojure also compiles to the Beam.
Yeah.
Now, thanks for your talk, guys. It was sort of like a conversation, not too hard to follow. So thank you.
All right. Thank you so much.
Thank you.
Bye.